So yes, hello everyone. Today I'll be talking about and demonstrating the Physics Grab Gem. So this is a third-party gem developed by my brother and I under the name Porcupine Factory. Please feel free to interrupt and ask any questions during the presentation. I'll just be demonstrating the gem in the context of a real level, so feel free to interject whenever. Some of you may have already seen our YouTube video or our new blog on the O3DE website about the gem, but if you're not familiar with it, the physics grab gem is basically enables realistic object interactions in your game. So for example, this would be like picking up and moving crates around or throwing barrels at an enemy NPC or like knocking over objects on a table and kind of just like fiddling around with stuff. If you're familiar with games like Half-Life 2 or Portal or like even like the Elder Scrolls games, it's kind of like that, but taken to a new level. Um, so a lot of games that have object interactions look like this. So the object kind of sticks to you and snaps into position as you move the camera, which kind of makes it look like the object is teleporting. It's definitely cool and it was innovative for its time, but not super realistic. This is because many games don't utilize physics for these interactions, and they often change the object translation or rotation directly, which causes the object to snap into position. And if they do use physics, they often apply like a really high force or velocity on the object to the point where the object still looks like it's just like snapping into position. I'm pretty sure this is how Half-Life 2 and Portal handle it. So the big question is, how is the physics grab gem different? So now I'll share the O3DE editor and demonstrate that if that's okay. Does everyone see the editor?
Yes.
Okay, great. So I have a project level set up here in the O3DE editor with the physics grab gem enabled and some interactable props. You can check out our YouTube video on how to download the gem through the project manager to set this up for yourself. But if I enter game mode here, actually, I'm going to adjust the view window here. So if I enter game mode here and walk over to this table and pick up this chair here and move it around, hopefully you'll notice on the stream that the motion is a bit different from the videos I showed you earlier. The chair has some weight to it, and you can tell it kind of bounces a bit as I move it around. And there's a subtle lag that makes it feel more realistic. The physics grab gem does this by applying forces and velocities in a realistic looking way. And it also utilizes a PID controller, which creates the spring-like motion with realistic damping, which in my opinion feels much more realistic and immersive. You can also, with the physics grab gem, you can rotate the object. You can change the distance so I can bring it closer to me or further away. And you can also throw it like that. You can also adjust these settings to kind of create the effect that you're looking for. So if I, for example, if I wanted to create more bounce in the chair, if I go over to my player character entity and go over to the physics grab component here, if I go over to advanced hold dynamics, and if I adjust some of these values, so if I increase the P gain to 130 and decrease the derivative gain to something like 8, if I go back and enter play mode again, if I go to this chair, the spring effect is a lot more, it's more exaggerated. So you can see it kind of like has an underdamped behavior and kind of oscillates towards the center of the screen. So if I go back here and change these settings back, you can also you can do a lot of cool stuff with this. For example, I have a chandelier set up here with a chain link, which you can kind of move around, grab it and move it around, which is pretty cool. It's set up with hinge joints on the chain links. Another cool feature, which I'll show here, is that if I go over to the physics grab gem and enable offset grab here, and I'll also disable tidal lock and increase the damping here. What this does is it lets you grab the object offset from the center of mass. So if I go over to the table here and grab this book at the corner, you'll see it kind of tilts around the grab point off the center of mass, has this realistic and natural looking tilt. So I can grab the corner here and it kind of rotates around there. And this is kind of like, I think, what the Elder Scrolls games do, which I think is a pretty cool effect. But yeah, that's another cool feature. So if I'm going to go back here and disable the offset grab gem, then turn that back on and go back to this. So those are just a few features of the gem. And to set the gem up, all you really need is a character controller. In this project, I have a player character entity set up here, right here, with a first person controller. So if I scroll down, you can see our first person controller here. I do recommend using a first person controller since that's what we used when designing the gem, but it could work with a third person controller with some tweaking. So when you first add the physics grab component to your project, you'll notice quite a few parameter groups here. So this input bindings group lets you change the string names for the different grabbing actions. So for example, the grab key or a throw key or a rotate key. So when you're setting up your input bindings in the asset editor, so I'll just open up the asset editor here. So I'm going to open up a input bindings file. So when you're setting these up, you want to make sure that the event names here match the names over here. So if I change the name of the grab key input binding in the physics grab component, I have to make sure I also change it here in the event name. So if I exit out of this so we can have some more room, if I open up this next group, the detection parameters. So these parameters are related to detecting objects. So you can adjust the distance of how close or how far you can detect an object, as well as the radius. So for example, if I change this, which is the sphere cast distance, if I change this to something like 10 meters, if I enter game mode, as you can see, I can grab the chair from really far away. So it basically sets the distance of the sphere cast, which is what's detecting the objects before I pick them up. If I go back here and reset that, you can also set the minimum distance here, which I've set to 0.2. And this is also where you set the collision layers and groups, which is kind of what filters out which objects you can or can't grab. So now I'll go over the hold parameters. This is a bunch of parameters related to detect, or rather it's related to holding and moving grabbed objects. So there's a lot of these here. So I'll just go over a few of them. The grab entity here is the entity that does the grabbing. So I'm using a camera in this level since we're in the first person perspective. So basically what this does is it makes the object follow the camera as I rotate it around. So you can see as I rotate my character and my camera, the object kind of follows the center point of the screen because the camera is basically used as a reference for the grabbing. So if I go back, this parameter right here, maintain grab. This is interesting because it lets you continue holding the object even if you turn really quick. So for example, if I go over here to this, actually, let's pick up the book. If I turn really quick, as you can tell, the book just keeps following me around. And if I go back to that parameter and turn it off, disable that. If I try to move really quick, it'll just kind of fall down. And the reason that's happening is because the sphere cast doesn't intersect with the book anymore. So it just kind of falls down. So if that's the kind of effect you're looking for in your game, it could be pretty cool. So I guess it's a little bit more realistic, but it's your choice whether you want that in your game or not. So another interesting feature is this next parameter, kinematic while held. So if I enable this, the object will basically snap into position and kind of stick to the character. This is similar to what we saw in the video example. So this is basically just setting the translation and rotation directly. It's a bit stiff in my opinion, but it could be useful in certain situations. So the option is there for you. Drop that. So I'm going to go back and disable that. So I'll disable that here. So I already went over the offset grab earlier. So I guess I'll go over the tidal lock now. So when I turn this tidal lock option off and I pick up the chair here, you'll notice as I turn and rotate, the chair continues facing that left wall. It doesn't rotate with the character. But if I go back and I turn that on, enter game mode, you'll see it kind of continues to face me. another interesting effect if you're looking for that in your game. So even if I rotate it like that, it'll just still continue to face me. So now I'll go ahead and skip over to the distance parameters. So here you can adjust the minimum and maximum grab distances. So if I, for example, this parameter here, max grab distance, if I change this to 10 meters, I can pick up the chair and move it really far back. So if I move back to this wall over here, I can move it really far back and I can control it from a fairly far distance. Make it bump into the chandelier. But I go back here and change that back. And I'll set up, or we'll look at the rotate parameters next. So rotate parameters has some cool features. So if you're using if you're using our first person controller, and you enable this parameter right here, freeze character rotation, basically what this does, it'll make it so you're, oops. That's a little bit too small. So that freeze character rotation, basically what that does is when I enter the rotate mode to rotate the chair, my character stops rotating. So my character's rotation and the rotation of the objects are both bound to the mouse delta X and delta Y. So basically what this does is it prevents me from rotating as I rotate the chair. So that's a cool effect if you want to do that for your game. But since this is specific to the first person controller that we made, this will only show up if you have the first person controller enabled in your project. If you don't have the first person controller, you can still achieve this using some of the methods that we exposed for scripting. So for example, if I open up a script canvas, just a random script canvas file here, we have a method called onRotateStart. So you can basically use like a method like this onRotateStart to set up some simple logic to have your character stop moving whenever you enter the rotate state. So I'll exit out of that. So a few other things in the rotate parameters. So this is also where you can set up the rotation sensitivity. So you can increase the speed or decrease the speed of how quickly you rotate objects. So this parameter here, the horizontal rotate scale, if I increase that to something like 2, and I enter game mode, oops, the chair will rotate a lot faster. So you can set the sensitivities there. Let's change that back. So now we'll skip ahead to the throw parameters. So here you can do things like change the throw impulse, which adjusts the force of the throw. So right now it's set to 11. If I increase this to something really high, like 50, and I'll grab this chair. I'll have to move really far back to this. If I move back and I throw the object, you can tell it throws it with a really hard force. And you can also decrease that to make the throw weaker if you'd like. So I'll change that back to 11. So another cool feature here is this one here. It's called Enable Chargeable Throw. So if I turn this on, basically this lets you charge and release the object instead of throwing it instantly. So if I enter game mode, if I grab this chair again, if I just tap the throw key, it'll do like a really weak throw. But then if I enter game mode again, I grab it, and if I hold the throw key for the full charge time and then release, it'll do like the full strength throw, basically. So if I go back and disable that, next we'll go over the advanced hold dynamics. This is the fun one. So this is where you can enable the PID controller. So PID stands for proportional, integral, and derivative. So it's a common algorithm used in areas like robotics or aerospace, and it's even used in common places like cruise control on your car or temperature controls in your house. Basically, PID controllers are used to help any system reach and maintain a target value smoothly. So in the Physics Grab Gem, the P, I, and D terms, they're used together to create the spring and damping effect, where the object bounces and overshoots or undershoots depending on how you tune it. And these three gains together, they help adjust the object's position based on an error, and the error is the difference between the object's current position and the target position. So I'll just demonstrate really quick what this does. So first I'm going to exaggerate this. I'll increase the proportional gain and decrease the derivative gain. And if I enter game mode, you'll notice this chair kind of oscillates a lot around the center point, has an exaggerated spring effect. And then if I turn the PID controller off, enter game mode, it'll use a simple velocity-based grab where the object just kind of gradually moves towards us. And I'll turn that back on really quick just to show the difference. Hopefully you guys can notice that on the stream. But yeah, that reintroduces that exaggerated underdamped behavior. And you can tune it to however you'd like, if you want subtle oscillations or more of a critically damped thing. So I'll go over this parameter, mass independent PID. So if I go enter game mode and I walk over to this book, which weighs less than 1 kilogram, and I move it around, you'll notice I can move it fairly easily, follows my camera. And then if I go back over here, over to this bench, which weighs almost 6 kilograms, you'll notice it kind of sags a bit because there's that gravitational force is pulling it down. And it's more difficult to move around. However, if I go back to that parameter, mass independent PID, and I turn that on, I'll show the difference there again. If I move this book again, it's still easy to move around. And then if I go to this bench again, it's a lot easier to move around. The gravitational force isn't pulling, well, we're applying more forces to the bench, so it feels a lot more like the book in that regard. So now I'll go over exactly what the PID terms are. So the held PID P gain, this is the proportional gain, and it applies a force that's directly proportional to how far the object is away from the target. So the farther the object is, the stronger it'll be pulled towards the target like a spring. And this number here controls the strength of the grab, and it also creates that oscillation effect. So for example, I'm going to turn that off. If I increase this to something like 200 and I enter game mode and move a chair around, you'll see it snaps really quickly to the center point. And the oscillations are they're faster. So they're higher frequency. So basically increases the strength of your grab while also contributing to the oscillations. Turn that back down. The held PID I gain, this is the integral gain. So what this does is it helps remove steady state error, which is like a constant external force like gravity or wind. And it does this by accumulating error over time and applying a corrective force that grows until the steady state offset is canceled out. So I'll try to demonstrate this here. If I lower the proportional gain and enter game mode and try to pick up this bench again, which is fairly heavy, when I pick it up, you can see the bench sags because gravity is pulling it down away from the center point of the screen. Now, if I go back and I increase the integral gain to something like 30 and go back to this bench, you can see it rises up to the center of the screen because the integral term is counteracting the force of gravity, which is pretty cool. And if I go back and set that back down to 0, oftentimes I still leave it at 0 because the proportional term here it's usually enough to counter something like gravity, but it really depends on your game because some games may have stronger gravity, some games may have weaker gravity. So the held PID D gain here, this is the derivative gain. So this looks at how fast the error is changing. So like how quickly the object approaches or leaves the target. It applies a force opposite to the rate of change, resisting motion as you approach the target. It's like the damping in a spring model, and increasing this number helps reduce overshoots and oscillations. So I'll kind of demonstrate that here. So if I reduce that again to like 8, so I'll decrease that, which should increase the oscillations. So the chair is oscillating around the center point here. And then if I go back and increase that to exaggerate the effect, this will introduce a damping effect. So if I grab this chair and move it, it's a lot smoother and kind of gradually goes towards the center position, because it basically counters the proportional force. So you kind of want to balance them, because if the derivative gain is too high, it could make the object feel slow and stiff. So you definitely want to balance the P and D terms together. So if you want to think of it intuitively, the P term, so if you're driving, the P term steers you back to the lane when you're off. The I term adjusts for constant wind pushing you sideways, and the D term eases off the wheel to avoid swerving too hard. And I won't be going over these two parameters. You can, if you would like to learn more about them, we have a YouTube video that you can check out, or we have a blog on the O3DE website you can check out as well. It kind of explains these two parameters, the integral limit and the derivative filter alpha. So this next group, which is also the last group, the advanced tidal lock dynamics. This is very similar to the advanced hold dynamics, but it uses the PID controller to adjust the object's rotation as it rotates to face you during the tidal lock. So I will exaggerate that by increasing the proportional term here to 130. Actually, I'll go a little higher. Let's do 140. And then decrease the derivative gain to something like 5. And enter game mode. I'm going to go over to this box because it'll help demonstrate what I'm showing. As I move it around, you can tell the box kind of like wiggles as it rotates to face you. And it kind of gives it like an animated bouncy effect, which I think is pretty cool. If I go back, and if I change this back to say 90 on the P gain, sorry, you may not see these, the name. So this is the P gain, I'll change that to 90, and then the derivative term, I'll increase that to 8, go back into game mode, and then do that again. Hopefully you can tell that the effect is a lot more subtle. It's still kind of like wiggles a little bit as I move it around, but it's a lot more subtle. So you can fine tune it to the exact kind of behavior you'd like in your game. But yeah, that's basically it. So that's a summary of the Physics Grab Gem. If you like having lots of interactivity in your games and want to help your game feel more immersive and realistic, give it a try. Does anyone have any questions?
I have some questions, but I'll let others go first.
Okay.
I have a question about it. So when you were showcasing the locked kind of like what Valve does with their interaction, does it also do the same thing as Valve does, where if you go up against a wall, the object will, obey physics and not collide with the wall?
Yes. So I'll use this box for an example. I can bump it into the wall.
I was talking about like the locked one, like where it's doing
Oh,
exactly
the
what
kinematic.
Valve does.
No. So I think what Valve does is, so if I turn that on, the kinematic, so that'll still clip through static objects. So I think what Valve does is I think they'd still use physics. So they use their velocity, but they set the velocity to like, actually, I'm not sure if they use velocity or forces, but I think they set the velocity or force to like an infinite number to where it basically looks like it's snapping. I think I might be able to demonstrate that actually. Let me see.
That'd be neat.
So if I turn that off, and if I use the simple, if I turn off the PID controller, it'll use the simple velocity-based grabbing. If I increase the grab response to something really high, like, I don't know, let's try 100, that may provide the same effect. Let me just see. Yeah, so it kind of It may need to be tuned a little bit, but it kind of actually. Let me turn off the.
It's
Turn
pretty
this off.
close.
Yeah, it should still collide. Yes, that's it's a little unstable, but maybe if I decrease that a little bit. So yeah, it'll take a little bit of tweaking, but it should achieve that. You just want the grab response to be high enough to the point where it almost looks like it sticks to the center of the screen.
Yeah, like it's pretty close to the result I was thinking of.
Yeah, but yeah, you can get close. There's a lot of parameters you can fine tune, but
Yeah, answers my question.
okay.
Okay. My question is one, how can people get access to your gem?
So we have so we have a GitHub where this gem is open source under the MIT license. So if you go to our GitHub, which you can find, I think that on the O3DE website, we have a blog about the gem and it's linked there, but you can also check out our YouTube video where we have a link to the GitHub. So there you can copy a link and you can use that through the project manager to download and install the gem. But you can also do it like the old fashioned way. You can clone the repository into your directory. So there's a couple ways to do it.
Yeah, I'll talk and see if there's a way we can better highlight, your gem and the location and stuff so people don't have to go searching for all of that. Because since it's fully open source and MIT licensed, it fully matches our license. So yeah,
Yeah, that'd be
and I
great.
think people will find this extremely useful.
Hopefully. I find this stuff interesting. So
And I just want to say awesome job, by the way.
thank you.
It was a great demo and it's also a great gem.
Thank you. Thank you for the opportunity to demonstrate it. And I hope people get some use out of it.